In the last video, we talked about some of the basic introductory things of mechanics and Newtonian mechanics. Now, in this second video of the chapter Introductory Ideas of Mechanics and Newtonian Mechanics, we are going to see the subchapter, the space and time, the frame of reference, the theory of the frame of reference. Now, in classical mechanics, we assume that the space and time are constant and the motion of a particle in space can be described by knowing its position at different instant of time. So, if we know the time and the point of occurrence of a thing, that is the motion, that may be a motion or some other thing, then both the things, that is the time and the point of occurrence or the position, taken together are called an event. In classical mechanics, we also further assume that there is a universal time scale. There is a universal time scale, and the geometry we use to define the position of the objects in space is Euclidean. So the geometry of space is Euclidean, and there is no limit in accuracy by which we can measure the position of the particle or the object. But in case of the very minute particles, in case of the quantum physics, we have to rely on we are restricted by the theory given by the Heisenberg, that is a Heisenberg uncertainty principle. So there is a limit in the accuracy by which we can measure the position of an event in the quantum world. Now, suppose in order to describe the motion, we have to describe the motion of a particle in space. Now, for that, we need to know its position at different instants of time. So the need of the choice of a reference body or coordinate system, so for that we need a choice of reference body or a coordinate system. Now, suppose we have a coordinate system which is attached to a rigid body, and we describe the position of the another body such that we are taken the rigid body as a constant or a fixed point. So in that case, the coordinate system is called a frame of reference, because we are measuring the position of the object, that may be moving or some other object, in accordance with the rigid body, the rigid fixed body. So that is a frame of reference, the rigid fixed body. Now, for the location of objects, the position vectors are drawn from the origin of the coordinate system. So you can see here that suppose we have a point P, and we have described this event in the position as xyz, and for that event we included this time t. So we for the position or for the position we have measured from the point O, the reference point of the frame of reference, that is point O. Now, this is good to know that the simplest frame of reference is a Cartesian coordinate system. Is a Cartesian coordinate system, and in that case, for describing the position, we have a position vector r, and the r is written in the form of r bar equals to x I cap plus y j cap plus z k cap. So this is the way we describe the motion, the position of an object in the Cartesian plane using the x, y, and z coordinate. Different events, we have different times, but the position may be same. So in that case, we had to use this function, that is r equals to rt, because the position then in that case will be a function of time. Now, to describe the velocity of the object, we have to derive we have to use derivative of this position vector r, and we'll get d by dt on the xi cap plus yj cap plus zk cap. And for measuring the acceleration of the object, we have to again differentiate the velocity vector using the time, and we will get a d square r by dt square. And if we again write it down, then we'll get d square by dt of xi cap and d square and dt of y by into j cap and d square dt of z into k cap, which will give us the relation between the acceleration and position vector with the double differentiation. So it was all about the space and time concept, and I will see you again in the next video with Newton's laws of motion, and we'll describe all the Newton's laws of motion, and we'll prove some of them with theoretically and some of them with some equations. So thank you so much.